Today we are going to discuss about solutions in the chapter some basic concepts of chemistry. So we are going to discuss about solutions and we are in the chapter some basic concepts of chemistry. What is a solution? That's the first definition. What is a solution? A solution is nothing but a homogeneous mixture of two or more components. It's a homogeneous mixture of two or more components. So how can we understand this? Let's take a solution. This solution I have created by adding salt. Salt means our table salt, that is sodium chloride. I have added this into water, that is H2O. So I took salt and I added it into water here and I mixed it thoroughly. Now I have two substances or two components in it. One component is sodium chloride and the other component is water. So I have two components in this particular glass here. Clear? And also the peculiarity of this mixture is that now since we have two components, we can call it as a mixture. So peculiarity of this mixture is that it is homogeneous or uniform throughout. So all throughout this, the distribution of NaCl in water will be uniform. Such a uniform mixture is called homogeneous mixture. And if you have a homogeneous mixture of more than one component means two or more components, then you can call it as a solution. So it is not only NaCl, you can add sugar into it. In addition to NaCl, you can add other salts like silver nitrate or any type of salt you can add into it. You add them, you mix them. Once if it is uniform, then we can call it as homogeneous mixture. If it is a homogeneous mixture, then we call it as a solution. Clear? Now if you are coming back to the example, I have added salt into water. So we have two components here. How can you differentiate these two components or the essential things that is required for a solution? Those are, one is solvent and other one is solute. So we have one solvent and one solute. The peculiarity is that solvent here, in our example, it is water, and this inside this glass we have only water molecules, so it is a pure substance, and I am going to add NaCl or salt into it, and this salt to itself too is a pure substance. So we have solvent, which is a pure substance, we have solute, which is also a pure substance. We are mixing them together and then we get a mixture. And if that mixture is homogeneous, we call it as a solution. Clear? So we have solvent, we have solute. When you mix them together, solvent and solute before mixing can be there in their pure form, and when you mix them, you will get a solution, a solvent. How can you differentiate between solvent and solute? Definition for solvent is component that is in excess. So if you take salt and water, you know that you will take excess of water. So this is in terms of number of moles. If you are comparing the number of moles between the two components that is mixing, one that is having excess or higher number of moles is called as an solvent. So what is solute? Something that is dissolved in solvent, or something whose number of moles is limited is called a solute. So when we mix two things together to make a solution, one thing that is in excess is called solvent and the other one that is dissolving in solvent is called solute. Clear? A solution can be prepared with more than one solute in a solvent. So solvent will be always one, but you can add more than one solute. You can add salt, you can add sugar, or you can add any number of solute into it. Clear? That's the definition. Solution is a homogeneous mixture of two or more components. So here in this example we have two components. In addition to that, you can add more solute into it. Basic thing is you will have only one solvent. That solvent is the component that is in excess. You can add solute number 1 as salt. You can add sugar also as a solute. So you can add different solute into it. Clear? So there will be more than 2 components inside it. One solvent, solute number 1, solute number 2, solute number 3, etc., etc. So as long as it is homogeneous, it's called a solution. Now, next topic is, what is a binary solution? Binary solutions. What are binary solutions? So in the previous slide, we were discussing about the definition of solution. Solution is nothing but homogeneous mixture having 2 or more components. Now here we are going to be more specific. We are dealing only with 2 components. In the previous slide it was 2 or more. Here we are going to deal with only 2 components. If a solution has only 2 components, then it is called a binary solution. If a solution is having only 2 components, it is called a binary solution. So like in the previous example, we saw that we have only one solvent and we have only one solute. If we are mixing them together, we will get a solution. So that means we have only 2 components, one solvent and only one solute. Such a solution is called binary solution. That means solutions having only 2 components. What are those 2 components? Solvent and a solute. The peculiarity of the physical state of this solution is that solution will have the same physical state of the solvent. So solvent, here you can see it is liquid in state, and the resulting solution is also having the liquid form. Next, what we are going to see is how to express the concentration of a solution. First of all, why it is important to know or express the concentration of a solution. So if you are having some type of disease, and if you are going to have a medicine for that, or if you are taking some type of supplements in the form of packed food, or if you are buying milk, so whatever you are going to get it from the market, if it is a solution, if that particular thing is a solution, a medicine is a solution, generally in liquid form it is a solution, or in solid form also it is a solution, or the things that you buy in the packed as a packed food is always a solution. So if it is a solution, generally it has to show the percentage or the concentration of that particular solution on that packet. Clear? So it is important to know how to express and what does this concentration means. So the next topic is what we are going to see is based on that concentration of a solution. There are different methods to express the concentration of a solution. There are various methods, and we are going to see one by one here in this list. Concentration can be expressed in mass percentage, volume percentage, mass by volume percentage, ppm means parts per million, then mole fraction, molarity, and normality. So there are even more methods to express the concentration, but in our plus 2 and in plus 1 and plus 2 we will learn about these methods, these are the methods that we are going to learn in these 2 years. But for now, in plus 1 we will restrict to 3 methods, that is mole fraction, molarity and molality. All the other methods, including these 3, we will learn again in plus 2 in the chapter solutions. So it is essential to learn this here in plus 1, because even though we will learn this in plus 2, it is essential to learn here, because in the coming chapters you will see these terms coming up in order to, whenever you are dealing with a solution. So whenever you're dealing with a solution, it is important to know at least these 3: mole fraction, molarity and molality. Percentage things that you already have learned, so in case if they are appearing, we will discuss it there. So in class 11 we have to learn more specifically about mole fraction, molarity and molality. So again, coming back, In order to express concentration of a solution, there are various methods that you can see in the list here, and one of these methods will normally be seen in the solutions that you buy from market in the form of food or in the form of medicine or any other uses. You buy a solution, you will see the concentration expressed by using any of these terms. So we are going to see in this chapter basically these three ways of expressing concentration. So first we are going to see about mole fraction. Mole fraction represented by the Greek alphabet chi I. So I means the component. Name of the component is I. So I want to find the mole fraction of the component I. So mole fraction of a component I in a solution X or chi I is equal to Ni divided by Ns. This is the formula. So I have various components in a solution. Let's say two components, and I want to find out a particular component. I am assuming its name as I. And if I want to find out the mole fraction of that particular component I in a solution, then the formula is chi I is equal to Ni divided by Ns. Ni divided by Ns. We have already learned what small letter n stands for. Small letter n means number of moles, isn't it? So n of I means number of moles of the component I divided by n of S means total number of moles in the of all the components in the solution. So let's see, Ni means number of moles of the component I. So we are trying to determine the mole fraction of a particular component I, and Ni is the number of moles of that particular component I in the solution. And what is Ns? Ns means total number of moles of all the components in the solution. Ns means total number of moles of all the components in a solution. Let's try to understand this using an example. So let us consider a solution made of two components. Let us assume that we have a binary solution. Binary solution means it is made up of two components. A solvent that is named as capital A and a solute that is named as capital B. Clear? So we have two components. One is solvent A and the other one is solute B. If number of moles of solvent A, that is Na, if number of moles of solvent A is equal to 100 mole, and Nb, that is number of moles of solute B, is equal to 5 mole. Let's assume that we have a binary solution in which solvent is A and solute is B, and the solvent is 100 moles and solute is 5 mole in that solution. So I want to find out Xb. Xb means here I am going to try to find out the mole fraction of B, solute. Clear? So according, if I am applying this into this formula, here instead of I have to substitute Xb. Xb is equal to Nb divided by Ns. So the ith component here is B. So Xb is equal to Nb divided by Ns. So what is Nb? Nb they have already provided, that is 5 mole. What is Ns? Ns means, again let's look at the definition, total number of moles of all the components in the solution. So we have in the solution two components. One is A and the other one is B. So we have Na 100 mole and B 5 mole. So what will be Ns? Ns is equal to Na plus Nb. So which is equal to 100 plus 5, which is 105 mole. So we have Nb now and we have Ns. You just substitute those values into this equation. So substituting, you will get Nb is equal to 5 mole divided by Ns is equal to 105 mole. So by solving this, you will get 0.048. Mole and mole get cancels out. So you will get a value like this, 0.048. Clear? And one thing you have to notice is that mole fraction does not have a unit. Mole fraction will not have a unit. Clear? So what you have noticed here is that you are always having a small number in the numerator, because you are talking about a particular component in the solution here, whereas in the denominator you are mentioning about the total number of moles, isn't it, in the solution. So this will be always a bigger value, this will be a small value. You are talking about mole fraction of B, so you have 5 mole here in the top. So if you're talking about mole fraction of solvent A, what will be the value here? It will be Na. Na is 100. Again, the value will be here then 100. That 100 is lower than 105. So whenever you are talking about taking such a calculation, what you are going to get is a fraction that is less than 1. Clear? That's why it has the name mole fraction. You are always dividing a small number in the numerator and larger number, that is total number of moles in the solution, in the denominator. So whatever you get, whenever you get an answer for this, it must be a fraction. This is how you can verify the answer for mole fraction. You will never get a value greater than 1. The value will be either 1 or less than 1. Clear? So mole fraction has no unit and it is always a fraction. Clear? Mole fraction of a binary solution. We are little bit elaborate about what we discussed in the previous slide. I have a solution and the solution name is S. In the solution, since it is a binary solution, we have only one solute and one solvent. So I have solvent A and solute B. This is a general case. We generally represent solvent in the name A and solute B. Or sometimes we used to represent it as 1 and solute as 2. And so solutions we have S, solvent either you can represent as A or 1, and solute either as B or 2. Clear? So number of moles of A is equal to Na and number of moles of B in that solution is equal to Nb. So what is the total number of moles in the solution? Ns is equal to Na plus Nb, that is Na plus Nb. So mole fraction of the component A, if I am calculating the mole fraction of A, solvent, that is psi A is equal to Na, that means number of moles of that component, divided by total number of moles of all the compounds in this solution, that is Ns. What is Ns? Ns is equal to Na plus Nb. So which is equal to Na divided by, I am substituting this value for Ns here, so Na plus Nb. So if you know the number of moles of solute and solvent, you can easily find out the mole fraction of the component A. Similarly, mole fraction of component B, Xb is equal to Nb by Ns. Again, Ns can be substituted with this value, that is Na plus Nb. Clear? This is how to find out the mole fraction of any component in a solution. Next is mole fraction of a solution, Xx. So far we have seen mole fraction of a component. Here, what is mole fraction of a solution? So whenever you are taking mole fraction of a component, you have to say that number of moles of that component. Here, since it is a solution, it is mole fraction, number of moles of the solution divided by total, it is again Ns. So total number of moles of all the compounds in the solution. Both are same. So Ns by Ns is equal to 1. Again, it is mole fraction of a solution. In the previous slide, we were saying mole fraction of a component in the solution. So mole fraction of a solution, if it is a solution, then it is number of moles of solution. It is the same as the total number of moles of all the compounds in the solution. So Ns divided by Ns is equal to 1. There is also another relationship, that is mole fraction of a solution is equal to, if the solution is a binary solution and if we have two components, solvent and solute, you add their mole fraction together. If you add their mole fraction together, you are supposed to get the mole fraction of solution. Let's see how we will get it. So xs equal to xa plus xb, or chi s is equal to chi a plus chi b. Let's see. So xs instead of chi a or xa, in the previous slide we have seen the expression for xa. How to get it? It's the mole fraction of component A, number of moles of component A divided by total number of components in the solution. Since we have only two components, that is Na plus Nb, plus mole fraction of B, that is Nb divided by Na plus Nb. If you solve this, you will get it like this: Na plus Nb divided by Na plus Nb. So both cancel out each other, that is equal to 1. Or in other ways, we can say that xa, so this is the value of 1 is the value of xs, isn't it? So if you're substituting that value into this equation, what we will get? Mole fraction of a solution xs is equal to xa plus xb equal to 1. So it is a very important equation. xa plus xb is equal to 1. Why? Here, if you can find out the mole fraction of one component, you can calculate the mole fraction of the other component in the binary solution. So that's why this equation is important. You just have to find out the mole fraction of one component. The other component will be 1 minus the known component. Okay, clear? So in this slide, we are going to see a problem based on the formulas that of mole fraction that we saw in the previous slides. So 10 gram of sodium chloride is dissolved in 100 gram of pure water. So 10 gram of sodium chloride is dissolved in 100 gram of pure water. What is the mole fraction of sodium chloride and water? So since we have only two components, it's a binary solution, and I need to find out the mole fraction of both the components, sodium chloride and water. Instead of number of moles, what they have provided is mass. So we know a formula from where we can calculate the number of moles from its mass, isn't it? So let's see. Number of moles of sodium chloride solute. Solute, by we have seen the previous slide, we have given the name Nb. So for generally for solute we call B. We call solute as B to differentiate between solute and solvent. Clear? For solvent we give the notation A, and for solute we give the notation B. So number of moles of NaCl solute, Nb, number of moles means N of B is equal to mass of B divided by molar mass. This is what we have learned in previous parts. Number of moles is equal to mass divided by molar mass. Since it is of B, we always give that subscript B. So W is given, that is 10 gram, and molar mass of sodium chloride, you just add the atomic mass of sodium and chlorine, that is 23 plus 35.5. You will get 58.5. So 23 of sodium and 35.5 of chlorine. You add them up, then it is its molar mass, 58.5. So 10 divided by 58.5, if you solve it, you will get the value 0.17 mole. Clear? Now, this is the number of moles of sodium chloride. But for finding the mole fraction, you need to find out the number of moles of both sodium chloride and water, isn't it? So I have find out the solute, that is sodium chloride, and excess is water. So 100 grams number of moles of water is equal to Na is equal to Wa divided by Ma. Number of moles of solvent water is equal to mass of water divided by molar mass of water, which is equal to mass is given 100 divided by molar mass 18. How you get 18 in water? The formula is H2O. O, the atomic mass is 16. For hydrogen we have 2 hydrogen, so total 2. 2 plus 16 is equal to 18. So molar mass is 18. 100 by 18 is equal to, when you solve this, you will get it as 5.56 moles. So you got the number of moles of solute and solvent. 0.17 of sodium chloride and 5.56 mole of water in this solution. Clear? Now it is easy. Mole fraction, you just apply it. Ns is equal to Na plus Nb. So the number of moles of solution. So solution is made up of A and B. You just add their number of moles. You will get ENS also 5.73 mole. So what is the mole fraction of sodium chloride? Xb is equal to the formula, applying the formula Nb by Ns. So Nb is 0.17, Ns is 5.73. You simply substitute here, you will get 0.03. This is the mole fraction. And as I have pointed out, we don't have the unit for the mole fraction. And for mole fraction of water, applying the formula of previous slide, XA is what we have to know. XB already found out. So XA is equal to 1 minus XB. From which equation we use this? XA plus XB is equal to 1. Mole fraction of the solution is equal to 1. So XA is equal to 1 minus XB. That is equal to 1 minus XB is 0.03, which is equal to 0.97. So this is how to find out the mole fraction. Mole fraction should be a value less than 1, isn't it? So mole fraction of a solute or a solvent will be always less than 1. So you can see the mole fraction is 1, and you add them up, then both of them will give the mole fraction of solution, that is equal to 1. Clear?